Okay, so today let's take a look at Lab 3. Lab 3, we're dealing with simple linear regression. And then for Lab 4, we're going to do multiple linear regression. And these two are the longest labs we have. So for Lab 3, here we are doing a simple linear regression. So simple here means you have one predictor and one response. And linear here means that you can only assess whether your x and y has a linear relationship. So it's a pretty simple setup. The regression model is one of the most popular models that we use every single day. So let's take a look at the data we have. So the data we have is called Internet Use and GDP. So basically, as you can see from the title, we're trying to investigate the relationship between the GDP of countries and the internet use. So here, there's a little bit of introduction here saying that in westernized countries, the internet is pretty common, but then in countries like, for example, this is a study that was conducted in 2001, saying that only about 1% of the households have internet in Nigeria. So we want to see, is there a relationship between these two things, okay? So the data set we have, the data is from the Human Development Report. It's a nonprofit organization, I think. We have three variables. So we have the name of the country, we have the internet use, and we have the GDP. The internet use is measured by the number of households per 1,000 that have access to internet. So it is like, so here, for example, for Norway, we're saying 34%, roughly 34.6% of households have access to the internet, and then the GDP is measured in the unit is not provided here, but we see that there are a few missing data. For example, for countries like Canada and Sweden, we don't have any numbers for the internet use, so there are a few missing data in the data set. Okay. So let's take a look at the first question. First question, so first we're going to answer the design part, so whether it's an observational study or experimental design. So first, here it's kind of different than the settings we studied before, because before we're always doing like a binary manipulation. In this case, if you think, we would think the GDP is your x, as that's what I think it would be, and then your internet will be y, because it's kind of like GDP is the cost. So if the country has larger GDP, then it means the country is richer, and then the consequence, which is the y, is the internet use. So here, so basically now we are saying if you are doing an experimental study, then you should be able to manipulate the GDP, which you can't, because all of these, you can't really manipulate any of these. So we are doing a pure observational study. Okay, so for this observational study, how the cases in the study were selected, you can read about it. I did not read about it, but you can read about that. Okay. And then it asks you whether you can generalize. So let's take a look at this. Oh my God, I don't think the website is really very well documented. I don't know. I'll come back to this later. But here, basically saying, we say if the samples are randomly selected, then we can do the generalization. If the sample is not randomly selected, then we can't generalize. Okay. And then here also asks about causal relationship. So again, because this is an observational study, so we can't make any causal claim. Because, for example, if you do find out that the country that with larger GDP does have a larger share of internet, it doesn't mean that this is caused by GDP, because there are also a lot of other reasons that could cause the internet use behavior, like things like in some countries, the based on history and lots of social, political related issues, there might be different point of view on the use of internet, and you can think of other reasons as well. And also, different GDP, different countries have different type of economic system. So a higher GDP doesn't really transfer to, for example, attention to education and other things. So yeah, so in general, we're saying if this is observational, then we can't make this causal relationship. Okay. Then let's do question 2 as well, and then okay, for question 2, we're making a scatter plot. So we're making a scatter plot of internet use versus GDP. So the y is internet use and x is GDP. We're going to make the scatter plot, and then we're going to comment a few things based on the scatter plot. Okay. So to make a scatter plot, we go to Graph Chart Builder, and then we do scatter plot, and then we're doing the simple one because we don't really have any color information. We're going to put the internet use as y, and then we're going to put GDP as x. Okay, and then let's take a look at the scatter plot. So there are a few things we're trying to answer here. Okay, so again, I changed my data a little bit, so the pattern might look a little bit different than yours. Okay, so first it asks you how strong is the relationship, and then ask you what's the shape. Is it linear or curved, whether it's increasing or decreasing, and whether there are any outliers. So first, for the strength, I would say it's relatively strong because we do see there's kind of like an increasing pattern here. It is quite linear, but then there's also a little bit of curve here, so it's not like super linear. So I would say roughly linear. And it's definitely increasing pattern. So we see that with increasing of GDP, we see an increase of internet use. There are a few outliers I would consider, like for this part, the pattern looks pretty clear, and then we have a few points here that seems to be different than the rest of them. Okay, so that's the scatter plot. So for question 3, we are investigating the effectiveness of log transformation. So here it asks you, does a linear model with a log transformation in one or both variable seem more appropriate? So answer the question by transforming both variables. First, transforming both variables, and then, what is this? God. Okay, so we're going to transfer both variables, and we're going to do the scatter plot again, and then we're going to look at the relationship. Okay, so let's make the transformation first. So you do transform compute variable. First, let's do a transformation of the variable GDP. And let's name this ln GDP. So ln GDP equals to the natural log, which you can find it here. So you can double click on this and then just put the variable GDP here. So we have the first log transformed variable. Let's do the same thing for internet. We're going to call this log internet. So let's put the variable internet here, so we have both of them. Okay, now we have both transformed variable. The question asks you to do a matrix scatter plot, so let's do scatter plot again. So graph chart builder, and then we're going to do a scatter plot. We're going to do a scatter plot matrix, so double click on this guy, and then we're going to put all the variables, all of them, in the box here. Okay, so and then internet, and then GDP, and then, okay, it doesn't really allow me to drag all of them. I have to do it one by one, then internet, and then log internet. Okay, and let's do okay. So we have the scatter plot matrix. Let's take a look at, so here it asks you to describe the pattern. Okay, so we already have the original internet versus GDP we have. Let's take a look at the log version. So this is the log versus log, this guy. And we do see that this one looks more linear than this guy, I would say. little bit better. So we say that the log transformation does make the linear relationship a little bit stronger. And this is just the log, and this is exponential. So that's question 3. Okay. So here it asks you which one seems to be more appropriate for a linear model. This one looks pretty good. Like these two definitely look not linear to me. Both of these look pretty good. I think this one is slightly better. Okay. Okay.